Assalamu alaikum. Welcome to lecture number 13 of the course on statistics and probability. Students, आपको याद होगा कि पिछले लेक्चर में मैंने आपके साथ कुछ बहुत इंटरेस्टिंग और इम्पोर्टेंट कॉन्सेप्ट्स डिस्कस किए थे. In particular, you will remember the Chebyshev's inequality, which gives you a certain minimum proportion of your data lying between specified intervals. Also, you will remember the empirical rule which is valid in case of unimodal, hump-shaped, approximately symmetric distributions. Also, towards the end of the last lecture, I discussed with you the 5-number summary. Today, I will discuss with you another interesting concept, which is the box and whisker plot, and it is directly associated with the 5-number summary. लेकिन पेशतर इसके कि मैं box and whisker plot की discussion start करूं, I would like to revise with you the concept of the 5-number summary. आपको याद होगा कि मैंने आपसे ये कहा था कि for any data set, when we have acquired information regarding the central tendency, the dispersion, and the shape of the distribution, we would like to identify and describe all these major characteristics of the data in a summarized format, and the 5-number summary is a useful device for this purpose. As you now see on the screen, a 5-number summary for any data set consists of the 5 quantities x0, q1, median, q3 and xm. आइए जरा उसकी जो interpretation है उसकी revision करते हैं. As I told you last time, for a perfectly symmetrical distribution, the distance between q1 and x tilde is exactly the same as the distance between x tilde and q3, and you can now see this on the screen. Also, for an absolutely symmetric distribution, the distance between x0 and q1 is exactly the same as the distance between q3 and xm. Another important point is that the arithmetic mean, the median, the mid-range and the mid-quartile range, they are all equal to the central point of our distribution. ये तो थी symmetric situation. And what is the situation in the case of a positively skewed distribution? As you can see on the screen, in this situation, the distance between xm and q3 is greater than the distance between x0 and q1. Also, in the case of a right-skewed distribution, the median is less than the mid-quartile range, and the mid-quartile range is less than the mid-range. Students, आपने पिछले लेक्चर में भी और आज के लेक्चर में भी नोट किया होगा कि I am using the word right-skewed distribution for the positively skewed distribution, and I use the term left-skewed distribution for the negatively skewed distribution. मैं जब इस तरह से कहती हूँ तो मेरा मतलब यही होता है कि अगर राइट स्क्यूड डिस्ट्रीब्यूशन कह रही हूँ तो इसका मतलब है कि जो राइट साइड वाली टेल है दैट इज लॉन्गर देन द अदर टेल. In the case of the left skewed distribution, the distance between x0 and q1 exceeds the distance between q3 and xm, as you now see on the screen. Also, in left skewed distributions, the mid-range is less than the mid-quartile range, and the mid-quartile range is less than the median. स्टूडेंट्स, ये सारी बातें जो मैंने आपके साथ पिछली मर्तबा भी की थी और आज रिपीट की हैं, these are reflected in the 5-number summary. You will remember that in the last lecture, I applied these concepts to an example, and I will revise it with you now. As you see on the screen, if we have data regarding the annual costs incurred by students attending public versus private colleges and universities, if we have data regarding the annual costs incurred by students attending public versus private colleges and universities in the United States of America, and in particular, supposing that our sample consists of 10 universities whose athletic programs are members of the Big Ten Conference, and the annual costs incurred for tuition fee, room, and board at the 10 schools belonging to Big Ten Conference are given as follows. For the Indiana University, $15.6 thousand, and for the Michigan State, $17.0 thousand, and so on. जैसा कि मैंने पिछली मर्तबा कहा था, अगर इस डेटा से हम 5-number summary develop करना चाहें, तो the first step would be to arrange the data in ascending order, and as you now see on the screen, the ordered array for this particular data set is 13.0, 14.3, 14.9, and so on, and the last value is $23.1 thousand. The first advantage of the ordered array is that we are able to locate x0, the smallest value, and xm, the largest, very easily. Also, the ordered array enables us to compute the median, the first quartile, and the third quartile. And for this particular data set, the median comes out to be $15.30 thousand. Q1 is equal to $14.90 thousand, and Q3 comes out to be $16.40 thousand. Therefore, the 5-number summary for this particular data set is 13.0, 14.9, 15.3, 16.4, and 23.1. These 5 numbers reflecting x0, q1, x tilde, q3, and xm in that order. और अगर हम इस 5-number summary को इस डेटा की शेप और इसके salient features को समझने के लिए इस्तेमाल करना चाहें, तो according to the rules that I gave you earlier, you will agree with me that the distribution of the annual cost data is positively skewed. I have come to this conclusion because of 2 reasons. Number 1, the distance from Q3 to XM, that is 6.7, greatly exceeds the distance from X0 to Q1, that is 1.9. And the second point, that if we compare the median, which is 15.3, and the mid-quartile range, which is 15.65 for this particular data set, and the mid-range, which is 18.05, we observe that the median is less than the mid-quartile range, and the mid-quartile range is less than the mid-range. So, जैसा कि मैंने last time कहा था, सारी discussion का लुब्बे लुबाब ये कि the 5-number summary is a simple yet effective way of describing the salient features of your data set and also to determine the direction of skewness without actually having to draw the histogram or the frequency polygon of your distribution. Students, मैंने आपके साथ 5 नंबर समरी का कॉन्सेप्ट जो हमने लास्ट टाइम किया था आज पूरी डिटेल के साथ दोबारा रिवाइज किया और इसकी वजह यह है कि जो इसके फौरन बाद नेक्स्ट कॉन्सेप्ट मैं आपके साथ डिस्कस करने लगी हूं दैट इज डायरेक्टली लिंक्ड with the 5 number summary. This next concept, as I said earlier, it is a very interesting diagram actually, and it is called the box and whisker plot. As you now see on the screen, in its simplest form, a box and whisker plot provides a graphical representation of the data through its 5 number summary. The plot consists of a box which is partitioned inside by a vertical line, and also the plot contains 2 horizontal lines, one on the left side and one on the right, and these are called whiskers. So the box and the whiskers together constitute the box and whisker plot. अब सवाल ये पैदा होता है कि ये जो बॉक्स है इसका साइज क्या होगा, जो whiskers हैं उनकी लंबाई क्या होगी और किस तरह से आप इसको प्लॉट करेंगे. So I will answer this question step by step. The first step, as you now see on the screen, is that the variable of interest, that is the x variable, it is represented on the horizontal axis. Next, a box is drawn in the space above the horizontal axis in such a way that the left end of the box aligns with the first quartile of our data set and the right end of the box aligns with the third quartile. After that, the box is divided into 2 parts by a vertical line that aligns with the median. Next, a line that is a whisker is extended from the left end of the box to a point that aligns with x naught, the smallest measurement in our data set. And last but not the least, another line, that is the other whisker, is extended from the right end of the box to a point that aligns with the largest measurement in the data set. So, in this manner, we get this very interesting plot, a box and 2 whiskers. Let me explain this point to you with the help of an example. Suppose that we have data regarding the downtime in hours recorded for 30 machines which are owned by a large manufacturing company. And it is known that the period of time covered was the same for all machines. The data regarding the downtime of the 30 machines is 4, 6, 1, 8, 1, 4, and so on. In order to construct the box and whisker plot, we need to locate the smallest and the largest observations in our data set, and these values are 1 and 13 respectively. Also, we need to compute the first quartile, the median, and the third quartile, and for this particular data set, these values come out to be 4, 5, and 8.25. As such, we obtain a box and whisker plot which you now see on the screen. Students, ये जो तीनों क्वार्टाइल्स हैं Q1, Q3 और X tilde, ये मैंने किस तरह कंप्यूट किए हैं? आपको याद होगा कि जब मैं आपके साथ क्वार्टाइल्स की डिस्कशन कर रही थी, I gave to you in detail the formulae that are valid in the case of the frequency distribution of a continuous variable. लेकिन मैंने बहुत ज़्यादा डिटेल में आपके साथ ये पॉइंट डिस्कस नहीं किया था कि how you would find the quartiles in case of raw data. But I hope that you have already studied quite a bit of material from your own textbook and from other books, and you do have an idea as to how to compute the quartiles in the case of raw data. In this particular example, as you now see on the screen, the first quartile is the 30 plus 1 over 4th, that is the 7.75th ordered measurement, and it comes out to be equal to 4. Similarly, the median is the 30 plus 1 by 2th, that is 15.5th measurement, and that comes out to be equal to 5. And in a similar way, the third quartile is 3 times 30 plus 1 by 4th, that is the 23.25th ordered measurement, and that comes out to be equal to 8.25. Students, the most important question is कि इस box and whisker plot को हम interpret किस तरह करेंगे? The point to understand is that this interesting and simple diagram gives us quite a lot of information. It gives us information regarding the spread, the location of concentration of the data values, and the shape of your distribution. In the example that we have just considered, the box and whisker plot reveals that 50% of the measurements are falling between 4 and 8.25. Also, the box and whisker plot indicates clearly that the median is 5 and the range is 12. And the most important point is, as regards the skewness of the distribution, that since the median line is closer to the left end of the box, hence the data are skewed to the right. Median line के बारे में जो मैंने आपसे अभी कहा, उसको खास तौर पर नोट कीजिए. I said that if the median line is closer to the left end of the box, it means that the data is skewed to the right. इसी तरह, if the median line is closer to the right end of the box, the distribution will be skewed to the left. And of course, for a perfectly symmetrical distribution, the median line will be neither closer to the left nor closer to the right, and it will be in the exact center of the box. तो ये तो हुआ एक पॉइंट कि आप अच्छी तरह से नोट करें कि उस बॉक्स के अंदर मीडियन लाइन, is it closer to the left, is it closer to the right, or is it exactly in the middle of the box. दूसरा equally important point ये है कि आप उसके whiskers जो हैं उनको गौर से देखें और नोट करें whether the left whisker is exactly equal to the right one, or is it that one of them is shorter than the other one. और एक बड़ा interesting relationship है between the point के कौन सा whisker छोटा है और कौन सा लंबा, and the point के median line box के left side के closer है या right side के. So, as you now see on the screen, for a negatively skewed distribution, the median line is closer to the right end of the box, and the whisker to the right is shorter than the whisker to the left. On the other hand, for a right skewed distribution, the median line is closer to the left end of the box, and the whisker to the left is shorter than the whisker to the right. Let us consolidate all these ideas by going back to the example of the 10 universities. As you will recall, the annual costs incurred on tuition fee, room and board for the 10 universities were available, and the 5-number summary of this data set came out to be x naught equal to 13.0, q1 14.9, x tilde 15.3, and so on. So, as you now see on the screen, the box and whisker plot for this particular data set is such that the median line is closer to the left end of the box and the left whisker is much shorter than the one on the right. So, इस box and whisker plot से हम क्या अखज़ करेंगे? According to the rules that I conveyed to you a short while ago, it is obvious from this box and whisker plot that the data of the annual costs of the students of these universities is positively skewed. मैं आपको encourage करूंगी कि अगरचे this is a very small data set, आप इसका frequency polygon या इसकी frequency curve draw करने की कोशिश करें और देखें कि does it look like a positively skewed distribution as indicated by the box and whisker plot. So, इस सारी discussion का gist ये है कि median line जिस side की तरफ होगी, skewness की direction उसके opposite होगी. और दूसरा point ये कि जिस side का whisker ज़्यादा लंबा होगा, skewness की direction उसी side की होगी. Students, the box and whisker plot comes under the realm of exploratory data analysis, or EDA as it is called, and this is a relatively new area in statistics. The diagrams that you will now see on the screen will show a comparison between the box and whisker plot and the more traditional method of drawing the frequency curve. The first diagram shows the situation where our distribution is absolutely symmetric, and as you see, in this case, the box and whisker plot is also absolutely symmetric. When I say symmetric, I mean that if you place a mirror vertically in the center of the box and whisker plot, you find that the left side of the plot is the mirror image of the right side. The lower diagram on the screen shows the situation of the rectangular distribution, which is the one, again, in which the left side is the mirror image of the right side. Although the rectangular distribution is not encountered as frequently as the hump-shaped distribution, but this is also a very useful distribution to describe the concept of absolute symmetry. Students, जैसा कि मैं आपसे पहले कह चुकी हूं, it is very unlikely that in a real life situation you will collect data whose distribution will be absolutely symmetrical. But in many situations we do get data which is approximately symmetrical. And box and whisker plot जो है, that will enable you to judge that very easily. अगर आपकी median line, it is almost in the middle of the box and the left whisker is almost as long as the right one, you can immediately say that this particular data set is approximately symmetrical. As stated earlier, in case of the negatively skewed distribution, the median line is closer to the right end of the box and the right whisker is shorter in length than the left one. On the other hand, in case of a positively skewed distribution, the median line is closer to the left end of the box and the left whisker is shorter in length than the right one. Positively skewed distribution को हम इस तरह से भी explain कर सकते हैं कि हम कहें कि the concentration of the data points is towards the low end of the scale. इसी तरह इसके opposite left skewed distribution के लिए हम कहेंगे that the concentration of the data points is towards the upper end of the scale. Universities वाले example में कुछ इसी तरह की situation थी कि approximately 75% of the values were concentrated on the lower end of the scale of the annual costs of the students, and the remaining approximately 25% were dispersed along the long right whisker of the box and whisker plot. Students, I have discussed with you the concept of the 5-number summary and the box and whisker plot in a lot of detail. I hope that you will study these concepts in depth and practice with a lot of questions. The next concept that I would like to pick up now is the Pearson's coefficient of skewness. इस सिलसिले में सबसे पहला point ये note करें कि we may think that by providing information regarding the center and the spread of the distribution, that is, by computing the mean and the standard deviation, we have done a perfectly adequate description of the data. But in reality, two distributions who have exactly the same mean and exactly the same standard deviation, they may be quite dissimilar. Let me explain this point to you with the help of an example. Suppose that we have data regarding the age of onset of nervous asthma in children, and we have this information regarding two categories of children, children of manual workers and children of non-manual workers. As you see on the screen, the data regarding the children of manual workers has frequencies 3, 9, 18, 18, 9 and 3 corresponding to the age groups 0 to 2, 3 to 5, 6 to 8, 9 to 11, 12 to 14 and 15 to 17 years. On the other hand, the frequencies for the children of the non-manual workers are 3, 12, 9, 27, 6 and 3. Although the total frequency is 60 for both distributions, I hope that you realize that the distributions are quite dissimilar. आपने देखा कि total frequency दोनों data sets के लिए 60 है, लेकिन I hope you realize by looking at those frequencies that the two distributions are quite dissimilar. अगर हम मीन और स्टैंडर्ड डिविएशन कंप्यूट करना चाहें, then we will do all those calculations which I conveyed to you earlier. And as you now see on the screen, the calculations for the children of manual workers and those for the children of non-manual workers provide all the sums that we require in order to substitute in the formulae of the mean and the standard deviation. The interesting point is that for both of these distributions, the mean age comes out to be 8.5 years and the standard deviation 3.61 years. लेकिन जैसा कि मैंने पहले कहा था, the shape of the two distributions will be quite different because the pattern of the frequencies for the two categories of children was quite different. So, as you now see on the screen, the distribution for the children of the manual workers is absolutely symmetric, whereas the distribution for the children of non-manual workers is quite different from symmetry. So, I hope that this point is clear that two distributions which are quite different with regard to skewness, they can have exactly the same arithmetic mean and the same standard deviation and yet be different in terms of skewness. The Pearson's coefficient of skewness is one method of measuring the skewness present in a data set. And as you now see on the screen, the Pearson's coefficient is given by mean minus mode over standard deviation. And if we apply the empirical relation between the mean, median and the mode, the Pearson's coefficient of skewness becomes 3 times the mean minus median divided by the standard deviation. As indicated earlier, in case of a positively skewed distribution, the mean is greater than the median and hence the Pearson's coefficient will come out to be positive. In the case of a negatively skewed distribution, the median is greater than the mean and the Pearson's coefficient comes out to be a negative quantity. And in case of an absolutely symmetric distribution, students, you already know that the mean and the median coincide and hence the Pearson's coefficient will be exactly equal to 0. Let us apply this concept to the example that we just considered. As you now see on the screen, for the children of the manual workers, the mean and median both are equal to 8.50 and hence the Pearson's coefficient is exactly 0. Whereas for the children of the non-manual workers, the mean is equal to 8.50 and the median is 9.16 and hence the Pearson's coefficient comes out to be minus 0.55. The negative answer in the case of children of non-manual workers indicates that the distribution for that category of children is negatively skewed. And I would like to encourage you, students, to look again at the frequency polygons of the two categories of children and to compare the results that you just obtained with what you see in that graph. Students, in today's lecture, we discussed various ways of ascertaining the skewness in our data set. And the last thing that I discussed is the Pearson's coefficient of skewness. Next time, I will begin with another very interesting measure, and that is called the Bowley's coefficient of skewness. In the meantime, I hope that you will enjoy revising and practicing the various concepts that you learned today. Until next time, Allah Hafiz.